Hello, and welcome to another episode of Celona Field Journal, where we bring you practical insights on private 5G. Today, our topic of conversation is zero trust strategy in a private 5G environment. And here to talk with us on this topic today, we have a security expert, Jennifer Manila. Jennifer, welcome to the show.
Hi, Andrew. It's great to join you today.
So, Jennifer, a big question that we get asked a lot in dealing with enterprise private 5G deployments is, what is a zero trust strategy, and what are kind of the key elements that enterprises require as part of this approach? Maybe we could just start off with a background on that topic and then get into how it specifically affects private 5G deployments.
Yeah, that's always a loaded question, and I think it's the first one everybody asks is, what does zero trust really mean? What does a zero trust strategy look like? And maybe most importantly, how is it different than what we've been trying to do for the past 5 to 10 years in the security space? And so, just to not give too long of an answer here, the little bit of background is that I think it tends to be looked at as, well, this is a buzzword. This is just the trend of the week, or, the acronym du jour. But there's a lot of really meat behind zero trust, and it is formalizing and giving some structure behind the things we've been asked to do as security professionals and organizations for a long time. And so we're talking about, really looking and diving into understanding all of the assets, including users and applications and their levels of privilege, networks, devices, in a way that has a level of depth of understanding beyond what we've been doing with our normal asset inventory. And then we start to layer on with that once we know what we have, which is, what are these users, devices, applications? What do they need access to? When do they need access? And how are we validating with more context that access that we're going to give to them, especially for privileged access? And so, an easy example that I think resonates with everybody is when we do talk about privileged access, because I think that's kind of low-hanging fruit, right? The people that have the keys to the kingdom, and they're allowed to go in and make, substantial changes to things like domain and directory structures, or network infrastructures, or entire application rights, is, in a zero trust model where instead of people having, like the root password or an admin password or a user account that has those privileges, we're kind of saying, all right, let's back off of that. And instead of having sort of this carte blanche access to everything in a group of endpoints or group of servers or group of services that you're administrating, that we're going to only give you the access to that specific server, service, application, device that you need, only to the degree that you need it, for the period that you need it. And we're validating a lot of the context of security while we do that, or before we grant that access. So what is the posture of not just my endpoint, which is something we've done for forever, if I'm accessing something, but maybe what's the posture of the resource I'm trying to access? Are there, CVEs or known vulnerabilities for that platform? What is the context of the network I'm accessing it to, through, or from, like the internet or the internal network or a WAN? Are there any specific threats, or is there a posture change in the security with that might influence whether or not I'm allowed to access that privileged resource? So that, coupled with things like zero trust network access, which really should be called zero trust application access, principles of just not exposing everything publicly to the internet in that more hybrid kind of cloud-based model that we have. So zero trust is real. And it is, foundationally dependent on that inventory and understanding what we have and the identity of each of those entities that we're dealing with.
Okay, so when we talk about device and user identification, then we have that in various forms already, right? Ranging from MAC addresses on Ethernet and Wi-Fi, usernames and passwords, and sometimes even certificates. Cellular devices, on the other hand, require a SIM profile for authentication. What makes that different as an quote unquote immutable identity, and what is the benefit of that?
Okay, well, let's talk about this for a second, because the first thing you let in with was MAC addresses. And, you and I both worked in this space for a long time, and we know a couple of different things, which is they can be spoofed. That's been longstanding. not only can they be spoofed, we're in this world where the IEEE has said don't use that for any type of unique identifier. And in fact, a lot of the wireless connected devices have MAC randomization where they're rotating through, within a fixed structure that's formalized of a not real MAC address. And so that just sort of, those two things sort of blows the whole concept of using a MAC address out of the water, especially when we're talking about authentication. So the one thing I've been harping on for a decade now is MAC addresses are never authentication. They're at best an assertion of an identity, right? We're kind of claiming to be a device or an entity when we do that, and there's no mechanism to verify that that's really who or what we are. So we do have some things like profiling and assessment. So we're, as NAC technologies sort of matured, what we started to do was watch the traffic and look for those indicators of, okay, suddenly the printer looks like a Linux server or something like that. So we have these things, but they're very reactive and they depend on us really tuning that infrastructure and being very specific about what we're looking for in those signatures. And that's always an uphill battle for us.
Okay, that makes sense. And then, so if we take it, to the next step of, on Ethernet and Wi-Fi networks, they've tried to do 802.1x with actual user identity authentication. So what's the difference between, let's say, an 802.1x identity in the classic enterprise space and a cellular SIM identity that we're introducing with private 5G?
There's a few differences there, and I'm sure you've seen some interesting mixing and matching and Frankensteining of authentication on traditional LAN and WLANs. But again, when we go back to a lot of that identity ends up being a MAC address, because even on an 802.1x secured network, what the manufacturers will tell the organizations to do is use that easy button of MAC authentication bypass. Okay, don't worry about it. We have this mechanism. We can use the MAC address. We can bypass the 1x as sort of a sub function of 1x. And so then what we've effectively done is just completely downgrade part of the network to MAC-based, authentication, even though it's really just an assertion of identity. And so we've sort of shot ourselves in the foot from a security perspective. And so I think, what's very different. So, okay, well, let me address we're not doing MAC authentication bypass, and we are using some type of identity username password combination or certificates. That's great. I love that. Frankly, it's not sustainable for most organizations on the wired network currently. Hopefully, in the future, we would hope for that to be a little bit easier. But not everything can participate in 802.1x. And even the things that should, a lot of times, especially if they're consumer grade solutions, they may say they do, but they don't function well, and the manufacturer has no intention of addressing that. So then we get into, okay, let's get past those hurdles and assume, okay, we can do it and it's going to work. Now we've got to somehow interface with those devices and get them whatever the credential is. And there are opportunities and processes and platforms to, do automated certificate enrollments. But what you're talking about at this point is, you've got your traditional network infrastructure, and now we've got all of these things we've added and bolted on that may not be in the purview of the networking team. And I'm sure you've seen stuff like that as well. So we kind of end up I don't want to call it duct taping, but we're sort of adding these modules and these other applications and workflows and processes around just to be able to identify some endpoint and get it on the network.
So maybe just to recap, kind of what I heard you talk about there was that maybe in the Wi-Fi space or in the Ethernet space, there's a mix of enterprise and consumer grade equipment typically on a network. The consumer grade equipment may not support 802.1x, and oftentimes does not. Whereas if we contrast that to the cellular ecosystem, consumer grade devices by default are required to have a SIM, an identity, and that authentication mechanism in order to get on the network. And there's no easy button, insecure alternative even possible within that ecosystem. And then the second thing I heard you say was that in a traditional LAN or WLAN environment, there's all these bolt-on add-ons that are outside of the network infrastructure. And I'm assuming you meant like AAA radius types of servers, identity stores like Active Directory or a PKI that are really complicated add-ons to integrate with the network infrastructure. And if we contrast that with cellular, the cellular infrastructure itself is authenticating those SIMs and those identities as part of the network function just by deploying the network with the user and authentication database that's built into the cellular infrastructure. So would that be a fair assessment?
Yeah. Oh, absolutely. Exactly. And, you get into, I'm kind of considering that most organizations have some type of radius services at this point. That's not a fair blanket statement, but most mid-market to enterprise have something there. But, getting the policies in place for that. So then you have the network infrastructure that has to be configured. You've got whether it's wired or wireless, works the same way. You've got the endpoints that require some sort of touching to make this work, whether it's pushing something out by group policy or, BYOD with a mobile device management solution, or manually touching devices or doing some quirky vendor specific thing to switch between SSIDs of different classes. Then the radius server, then the directory services, which could be a directory or could be, some database or text list of types of endpoints, like in headless devices. Then you get into, we're talking about, certificates. So now you're probably talking about a certificate server and service set, which is its own can of worms and its own sort of vocation in the world of security, managing a PKI infrastructure and the keys, the key rotations and the backups for that. And then the revocation list for that it's not just there's no easy button for that. So yes, absolutely. There's all of these things. And now we're not even talking about being able, the aspect of monitoring and doing incident response for these things. This is purely just to get the authentication working.
Okay. So can enterprises simplify their security ecosystem? Given they've had some complicated solutions in the past for endpoint profiling and network admission control. Are those required with a 5G LAN, or are those kind of replacing those kind of functions?
Well, there's a kind of two-pronged answer to that. I wouldn't say they are required. I will maybe give some cases where there might be opportunities in the future for that to be an optional value add, depending on specific use cases. But, when we talk about Wi-Fi, and we're talking about being able to do, identity authentication, and then some type of role-based access, right? Whatever that's going to mean, put it in a dynamic VLAN, downloadable ACL, whatever. The steps, we've already talked about the components of that, right? The different kind of gears we need to make that happen. The steps of that are pretty myriad. So if we have an endpoint where we don't necessarily have, let's say, a certificate installed, which is most endpoints, frankly, because we have things like HVAC controls and printers and screencasting devices and all of these kind of everything now. We're talking about how do we figure out what that thing is? Because when you do a network access control, project, and I've done many over the past 15, 16 years, even if you have full visibility to everything on the network. And one of the things I like about some of the NAC products is it doesn't even need an IP address. Anything that has a layer 2 connection to the network, we can see it. At least see something about it. And let's say MAC address, because that's usually the first visibility we get. So then our challenges and our exercise is, how do we start to carve out and figure out what those things are? So let's pretend like random MAC addresses don't exist for just a minute, because there's no hope of that purely by MAC address. So we're going to do things like, match that prefix on the MAC address to see if we can tell who the manufacturer was. That maybe gets us at best 20% of the endpoints. And typically that's more like less, around the 10% mark, simply because that is specific to that NIC. And, one manufacturer makes NICs for all kinds of different products. So, and then we get into, okay, well, we know it's I don't know, we know it's HP or we know it's Cisco. Well, that's not helpful because Cisco makes phones and they make TVs and they make cameras and they make everything. So that's not very helpful either. So then we start to get into, now we've got to let's look at the traffic, or let's inspect the device in some way. So now we're talking about, if we're inspecting the device, the equivalent of something like a light in map scan, or a very specific type of scan where we're looking at what ports are open. What is the HTTP header if it has a UI to log into, right? So we're doing these things. Now, sometimes in doing that, we can actually kill an endpoint if it's not designed to take that kind of traffic, unfortunately. So then we say, okay, well, let's just passively watch the traffic. So now that's another platform and a system that is not inexpensive to try to watch the traffic from that endpoint and see what it's doing and who it's talking to. And if that's encrypted, of course, good luck there. So that's just the first hurdle of what are these things? When we do a NAC project, that is 80% of the time or more, figuring out what all of the things in the network are. So when you look at something like a 5G LAN or private cellular infrastructure, because the endpoints are provisioned, and I'm not talking about, guest and neutral host stuff, but let's, in your enterprise, if you're using cellular as you would a WLAN, you're provisioning those endpoints. So you know what they are, because they can't possibly be on your network if you didn't provision them. And so that one feature of private cellular knocks off 80-something% of the time and the effort that we spend in trying to do authentication and authorization of network devices.
Definitely sounds like there's some room for simplification there of these NAC projects and security. Yeah. So maybe we'll wrap up our conversation with one last topic, and that is segmentation. Now, you've talked about, when you describe zero trust strategy within an enterprise, that it's more user identity and application centric. What role does traditional network segmentation have in a zero trust strategy? And maybe we could lead that into, how that is implemented in a private 5G type of scenario.
Sure. And I'm going to give you the industry party line first, and I'm going to tell you why I think that's wrong. So, the party line with that is, the idea of zero trust is we're removing inherent trust. And so our traditional network, and I'm specifically talking about network segmentation, not data center or workload or service microsegmentation. So network microsegmentation, what we've done is what? We've got VLANs, we've got VRFs, we've got ACLs, we've got these different ways to segment. For the most part, everything we've had up until this point is still putting those endpoints with some level of access to a subset of the network. It rarely is it a one-to-one relationship of this endpoint only has access to these set of resources that are specified as a one-to-one relationship, because that is absolutely unimaginably complicated. Anybody that's written an ACL or managed firewall rules knows that's just not possible. So the party line in InfoSec with zero trust is we're removing inherent trust, which includes not putting endpoints in a subset of a network where they have access to other things that they don't need access to. So what zero trust informs us to do is, don't drop the printers into a printer VLAN, because this printer doesn't need access to that printer. Don't drop casting devices into a VLAN, et cetera, et cetera. We keep going. Same thing with biomedical, same thing with OT devices, all of that, right? But the reality is, the people that are saying that are used to dealing with software, and their use cases with zero trust are primarily user to resource access, or that data center workload segmentation where we're talking about servers to server, service to service, in which case all of those scenarios, we have an opportunity to load an agent or to do something that is like a dissolvable agent that's not persistent on the endpoint, which gets very granular level of control over that user device. That model breaks when we get to these things like headless devices and IoT and network devices, right? So I'm going to peel back from that for a minute and say it's not always possible and reasonable to do one-to-one policies. There are network-based solutions that are kind of do micro-segmentation in the way that they basically hijack. They're the DNS, they serve DHCP, they're the default gateway, and therefore that endpoint can only talk to this central master control entity that then decides what it can talk to. But those models don't include the identification and the authentication that we're really striving for in zero trust. And so, sorry, long answer for, segmentation is much more complicated when we talk about it on the network than it is when we talk about it with some of the other use cases with zero trust. And so we don't have the same options available to us. We have to be more creative. We're getting to the point where we're going to be able to use things like ZTNA agents. And the interesting thing with that is, as we get into private cellular, we can install those sorts of agents on those endpoints. We'll be able to have that same type of control and policy set on traditional endpoints. And then even just within the private cellular ecosystem, all of that slicing and dicing that gets done over the air, and then the manufacturers and Celona, of course, having some secret sauce with the micro slicing and doing segmentation back through the wired side, gives us a lot more opportunity, even without a different application device or control, to be more granular, intentional about that access.
Okay, so would it be fair to characterize zero trust as kind of a maturing approach to network security in particular, and potentially, as somebody who did security in my background, like segmentation still has a place in a layered security approach?
Oh yeah, absolutely.
Okay.
Absolutely.
Well, Jennifer, I want to thank you for being with us here today.
Thanks for having me. Great conversation.
So if you enjoyed today's topic on zero trust network security in a private 5G world, please continue to watch, as we have a few more security episodes coming up. And you can always look for additional content on 5G on Celona's website. That is celona.io/journey to start your private 5G journey. So thank you all for listening today, and catch the next episode with you soon.